Picture this. You're on a massive ship, hundreds of miles from land, in the middle of a huge empty ocean. It's basically a floating city, just humming with electrical power. But what happens if that power is suddenly threatened? What's the one thing that stands between that floating city and a total disaster? Well, let's find out.
And that's a really important question, right? Because a ship without power, that's not just some inconvenience. It's a vessel in serious, serious danger. But lucky for everyone on board, there's this incredibly smart automatic system that's always standing guard, a silent hero we're about to get to know. You know, every good story needs a villain. And in the world of maritime engineering, the biggest, baddest villain you can imagine is a total blackout. So, first things first, let's really understand what's at stake here.
I mean, when the power goes out on a ship, it's not just the cabin lights. We're talking about the ship's brain and its muscles just shutting down. The systems that steer it, the ones that navigate through dangerous waters, even the alarms, they all go dark. The ship becomes this ghost vessel, totally adrift, blind, and it can't respond to anything. It is the absolute nightmare scenario for any captain.
So how do you stop that nightmare from ever happening? Well, the solution is as brilliant as it is simple, and it all starts with an idea that you've probably dealt with in your own home.
Just think about it for a sec. If the power in your house starts to flicker because you've got the AC blasting, the microwave going, and the TV on, what do? You instinctively run to turn something off to keep the main breaker from tripping, right? You prioritize what's essential, like maybe keeping the lights on.
Well, a ship does the exact same thing. But here's the kicker. It doesn't have time for a person to run and flip a switch. This whole process is completely automatic, and it happens in the blink of an eye. We're talking a fraction of a second. And it has to be that fast, because out at sea, there is zero room for error.
And this brings us to the hero of our story, the Ship Preferential Trip System. It's this super smart protective system, and its entire job is to make a split-second decision to sacrifice the non-essentials in order to save the entire ship. It's really a masterpiece of automated high-stakes decision-making.
Its core mission is pretty straightforward, but so important. First, it acts like a ruthless bodyguard, automatically disconnecting things that aren't absolutely necessary. Second, by doing that, it guarantees that the essential systems keep running. And what's the ultimate goal? To stop a catastrophic total blackout from ever happening.
Okay, so this is the really interesting part. How does this system make these, life or death decisions about electricity? How does it know what to sacrifice and what to save? Well, it all comes down to a super strict, pre-programmed priority list.
So, on one side, you've got the VIPs, the untouchables. These are things like the steering gear, the navigation lights, the engine controls, things that are totally non-negotiable for the ship's survival. And then on the other side, you've got what you could call the sacrificial lambs, the air conditioning, the kitchen equipment, even the laundry. Yeah, they're nice to have, but in a crisis, they're the first to go to save the ship.
And all of this happens in a flash. The instant the system's sensors even get a hint of an overload on a generator, boom, it detects it. Instantly, the preferential trip kicks in and sheds the first group of non-essential loads. If that's not enough, it sheds another group and another until the power load is stable. It's just a relentless, lightning-fast process of self-preservation.
Okay, so that's the theory, right? But how does this brilliant system actually perform when the waves are high and the stakes are real? Let's look at a few real-world scenarios. So, picture this. A ship has two generators running just fine, and then suddenly, bam, one of them fails. All of that electrical demand instantly rushes over to the one generator that's still working, pushing it way toward a critical overload. This is the exact moment a total blackout could happen. But before it does, the preferential trip system jumps in, instantly shedding non-essential loads to keep that last generator, that last lifeline, humming.
Or how about this? A ship is trying to dock. It's a really delicate and power-hungry operation. The system is smart enough to know that, in that moment, the thrusters and steering gear are the absolute top priority. It will automatically cut power to other things like the AC just to make sure every last bit of available power can go to maneuvering safely. It's just an incredibly intelligent design.
And in the absolute worst-case scenarios, like a fire or a flood, this system becomes a literal lifesaver. It's that unseen hand making sure power is getting to the most critical safety systems, the fire pumps, the emergency lighting, the very tools the crew needs to fight the disaster and save lives.
Now look, a system this critical can't just be a good idea on a blueprint.
It has to be proven to work every single time, without fail. Its reliability is completely non-negotiable. And this isn't just some optional feature or a clever piece of engineering. It's a legal requirement. International maritime law, guided by the highest safety standards, demands that this system is installed and tested rigorously. Its reliability isn't just a feature, it's a promise of safety to every single person on board that ship. And that testing is relentless. From the very first moment a ship is built, this system is put through its paces. It's tested again during annual surveys, and again during major 5-year inspections. And you better believe if any significant work is done on the power system, it gets tested all over again. It's a system that's constantly being proven, constantly being verified, so that it can be trusted when it matters most. So let's bring it all home with one final question. We've seen the danger, we've met the automated hero, and we've watched it in action. What do we call this automated guardian?
It's the preferential trip system, and it's so much more than just a switch, isn't it? It's the intelligent safeguard, the automated sentinel that stands between a fully operational ship and a powerless vessel just adrift at sea. It's the reason why, when things go wrong, the systems that matter most stay on.